I hope you're having a good time here, just like I am. So, before I start, I would like to know who of you already uses Json Web Tokens? Just, wow, that's a lot. Cool. So today, I'll be sharing with you basically how I've managed to simplify my API, be happier using Json Web Tokens, and obviously things were also a bit faster as well. But before talking about Json Web Tokens, we need to talk about tokens. What are tokens, and what the hell should we care about that? The most common use case for tokens are sessions, and I think you're quite familiar with that. So when we work with sessions, we have a browser, a server, and a database where we store the user information. Everything starts with the browser sending the credentials of the user, like the email and password. The server will talk to the database and validate the information. And finally, it will create a nice response saying, OK, everything is fine. Here's your cookie for the session you created. So the cookie contains this part. That ABC123, which is obviously just an example, it's a token. It's an identifier that binds the session to the data that you're storing on the server side, right? So when the client sends a new request, it will always send the cookie along with the payload or just the request data. And inside of one of the cookies will be the session ID with the identifier you created. The server will then read the session data, possibly talk to the database to get more information about who's actually using that session, and present the information, which is, in this case, hello, John. But when you work with APIs, things are not like that, because APIs should be stateless, right? Ideally. So that means you shouldn't store session information in the server side, but rather in the client side. About 3 years ago, I had a mission. The plan was to create an API, and basically the idea was, OK, we're going to create tokens and store the tokens in a database. So we knew when the token was created, when it will expire. Of course, this is just an example. We didn't use JSON to store things, but you can see that we had an identifier, the user ID that was using that session, and the scope of the permissions that the user could use, basically, on the API. And if you imagine, you can see that things will basically grow, right? So every new credential, we will have more information, new tokens, and new tokens, and new tokens, and new tokens. Because planning is hard, and obviously we forgot to clean up the database, right? So it was wonderful, right? Everything was stored in there, the database. The table was getting bigger and bigger and bigger, and we had to create in the middle of the thing a cron job or any kind of thing that was running in the background to clean up the expired tokens, right? And I was really happy. The only thing I was able to think of was that must be something simpler, because that complexity is a bit too much. Talk into the database every single request to know if the token is valid, or I don't know if it has the correct scope or any kind of thing, right? My name is Cobucci. I'm actually Brazilian. I work at Usabila here in Amsterdam. I moved here about 2 years ago. I am a core contributor on Doctrine, and I'm also an organizer on Amsterdam PHP. So if you live in Amsterdam, please join us. And after spending a lot of time researching and crying because of my complexity, I found a good solution for my problems. It was called José, or José, whatever you want to call it. And basically is a set of specs that defines how can you create signatures and even encrypt data using JSON objects. So let's cut a crap, and I'm going to show you what a JSON Web Token looks like. That's it. There's nothing like complex here, but if you look closer, you can find something that you can identify a pattern here. It looks like a base64 encoded string, right? If you don't know what is base64, just put one thing in your mind. It's not encryption. Please, keep this. So base64 is basically a way to encode binary and non-binary data into a binary safe string. And it uses A to Z, uppercase and lowercase, zeros, 0 to 9, and plus, slashes, and equals characters as like equal will be a padding string. But you can see here that we have some dots. And this is not part of a base64 encoded string, right? For a JSON Web Token, the dot means a separator. So if we move things a bit, it will look like this. JSON Web Tokens, it uses a variation of base64, which is called base64 URLs. That means that every token that you use is safe to be used as URL. So you can send it as part of the path of the URL or the query string. And the variation basically consists on this. It changes some characters and removes the equal sign. So in PHP, it will look like this, a function to encode base64 to base64 URL. So you have the data, you encode it with base64, then you remove, you swap the characters, and then you remove the padding to decode a base64 URL. It will be something like this. If we apply that algorithm into this string, like the two parts, you will see here. This will be the result. And then you think, wow, I have a JSON now. I can do anything, right? And that's essentially it. The power of a JSON Web Token is that you can put whatever data you want into the second part of the token. We're going to talk about this. But first, let me show you how can you use it. The most common, again, is authentication. So for APIs, you don't have necessarily a browser. You have a client, the API, and in our case, it's just a database. So again, the client sends you the data to authenticate the user. The API, using the database, it will validate the data, will check if everything is correct, and create a token. That token will contain some magical information like, okay, it was issued by this host, it is permitted for this client, and it will expire in X time. This token is returned as part of the response. You could also use cookies for that. And the client, on the next request, should send the authorization token. In this case, I'm using the authorization header of HTTP, but you could also use cookies again. And the nice thing here about JSON Web Tokens is when the server, the API in this case, receives the token, it doesn't need to go to the database to check things like, is it expired or can it be used now? Was it issued by me or by a different issuer? And this simplifies a lot of stuff. Then you think, okay, but OAuth 2, how does it fit on this story? OAuth 2 is a very nice concept, but some APIs simply don't need to use OAuth 2. However, if you do want to do that, the access token can be, you can use the JSON Web Token as the access token, because usually the access token is basically a random string. You can use a smart token instead. Another use case, and that's a bit opinionated, let's say that, if you want to have completely stateless sessions. So let's take another look at sessions. When you do a session start on PHP, usually, like if you don't change any configuration, you will have this scenario. The web server will have a file that points to the same identifier that you have. Every time the client sends a new request, the server will read the file that matches that identifier and retrieve the data. But what happens if you have this? A load balancer in the middle and multiple servers. Usually you have two ways to deal with this. The first one is to remove the persistence from the server using a database or a cache layer to store the session data. And the second is to essentially create sticky sessions. That means the load balancer will know which server the client was sent to. So if you send 2 requests, the load balancer will always send you to the correct server. Of course, you create some overhead on both solutions, but you could also do it completely stateless. So you have a JSON Web Token there, and every time you change the token, like add a new data to the token, you simply create a new token, and then continuously you just use the cookies. However, this practice has basically a lot of constraints. You have to really know what you're doing and know if the stateless session is something that you want to have, because probably you'll compromise security on your application, right? So if you're mitigating these issues, then you're free to go. You can download the library here on Packages, and it's a PSR 7 Meteor that basically handles the session loading, and you just read and write to the session. It's quite handy. What else can you do? There's no limit here. You can do Csrf tokens. You can, do you know that link, like password reset links, that they have a time to be used? And usually the way you do is send a identifier there. So you put in the link an identifier, and that identifier you have the entry on the database, and you validate if it is still if it can be used or if it is expired or not. You could replace that identifier and the complexity of talking to the database all the time by a JSON Web Token, and you will simply say, okay, is this token valid? No, so go away, you cannot use it anymore. Simple. Or if you want to have, again, links on emails to log in automatically when the user clicks on the link, you can use Json Web Tokens as well. But, okay, how can we understand everything and know what's going on inside of the web token? So again, this is the basic structure. The first part contains all the headers that are basically metadata of the token, what it's about, and if it is signed, what's the algorithm it's using, and the list of claims. That's the part where you can go crazy and add anything you would like to add, basically. And we have three big categories of claims. We have registered claims that are claims that you cannot use changing the meaning. So if you're using that one, you have to follow the standard and just using it in the right context. The public claims are basically commonly used claims that people are sharing and they're planning to standardize sometime. And private claims, like this one, user, is something that you decided to use on your application, and only you and the consumers of your application know about and how to use and how to understand that claim. To recap, the token is encoded using base64 URL and concatenated with some dots. And if we do this, this is the result. Cool? But, you know, this is not encrypted. This is just encoded. So can we really rely on the information that is there? Like, it can just be modified by somewhere else. And how can we make sure that the integrity of the token, it wasn't changed and anything like that? For that, we can use signatures. So we get the list of headers and the list of claims. We encode them. Without the last dot, we use that as a payload to a hashing algorithm. So with a key, you create a signature for your content, and then you also encode that content and put it together with a token. This way, you can guarantee that if someone changes any claim, you will know of that, right? On a PHP simplistic way, it's basically this. You have a list of claims. In this case, they are arrays, so you have to do a JSON encoding up front. You do the base64 URL encoding for the claims and for the headers. You concatenate them, use them as payload to a hashing algorithm, and put everything together, encoding the payload, the signature, and put everything together. But what kind of algorithm can we use to sign tokens? The specification basically says that all of this can be used. Every single implementation must have the HMAC 256. The RSA and the ECDSA, they are optional or recommended. So it's up for the people that implement the specification to basically make them available for you. What I personally recommend is to use RSA, because RSA is an asymmetric hashing algorithm, which means that it uses a public and a private key. So in order to create a hash, you use a private key, and in order to validate, it uses a public key. So you can share the public key, and you won't compromise security. ECDSA is also an asymmetric algorithm. However, when you do some benchmarks and how you compare them, RSA is a bit faster to validate tokens or signatures. And that's the operation that you will basically do more often, because you create the token, and that token will be probably valid for some time. So you will have plenty of requests to validate the token, but not many to create new tokens. So if we get this, I'm using now HMAC 256 to create a signature for this data with that key, and the result is basically this. But someone can just say, okay, but for this data, like you can see that it's not that much data, and you have a big, not really big, but it's not short string. So if you want to pass that as part of the request and or query string, whatever, that's something you need to think of. Like, how much data should I add to the token? Usually, you should think about the application you're using and how you're planning to use the token. If you're sending on query strings, you might have limits. If you're sending as cookie, you might have limits. But if you're deciding to use as WebSocket authentication, you don't have any kind of limit, hard limit for such thing. As I said before, we have some registered claims. They are basically things that if you're going to use, you should use with the correct meaning. We have then, on the left, JSON token ID is a unique identifier for the token, so that if you're doing any kind of operation and you need to make sure that this token is unique, you can rely on this ID and use it to store on different things and do, you can do a lot of things there, just with the token ID. Issuer identifies who created the token. Audience identifies what are the clients that are allowed to use or consume the token. The subject is, what is the token about? And these claims, they are case sensitive. So it's really important to when you're creating a token, to use the correct case, otherwise you won't be able to validate it properly. And in terms of time, you can use the 3 last claims: issued at, expires at, and not before. So the first only tells you when the token was issued. The second is like the maximum time that the token can be used, and the not before is the minimum time. So that allows you to do a lot of things and control the token in a very nice way. Let's say if you're issuing a token right now, but it can only be used 5 minutes from now, and it will expire in 1 hour. It's up to you to decide. You have that freedom, which is quite nice. When you're creating an API, especially when you have a lot of features to control regarding user management, sometimes you need to revoke tokens, like the user was removed. So all the tokens should be invalid from now on, because we don't want them to use the system anymore. How can we do that? The JSON token ID allows you to have the identifier. So with that identifier, you can use either a blacklist or a whitelist to manage the relationship with users and tokens. And if you just want to blacklist things, you can say that when this token, when you're doing something, the token A cannot be used anymore. But that example of user management, the whitelisting thing is nicer in my opinion, because you can just say, okay, every time you create a token, you append the identifier of this token to a storage system like Redis or something like this, and you link that token with the user ID. Every time you validate a token, you check if the token information is correct, but you also validate if the token ID is in the whitelist. If it is not, you reject the token. And when you remove the user or disable the user, you can just remove all the tokens from the whitelist, and the revocation is done. What kind of libraries and how can we find about and how can we use that? If you go to JWT.io, you find this nice list of libraries. One really cool thing about Json Web Tokens is that you can use in any language. You can use in Python, Ruby, JavaScript, Java, .NET, and this website contains a list of many implementations in different languages. It also has a debugger, so if you copy the token and paste it there, you can see what's in the token just to know what's going on and validate things. When I started that journey of trying to simplify things, and I discovered the Json Web Tokens, I looked at the existing implementations and I said, okay, they are awesome, but I think the design decisions are not so good. So I decided to create my own library. And we are now on the third major release. That's the latest stable version. And we are about to create the next major release, which is the one I'm going to show you a bit. But if you look at Cobucci/JWT, you can find who's using their packages available to plug it in: Laravel, Zen Framework, Symfony, and if you use OAuth2, the OAuth2 server from the PHP extraordinary packages, you can find the PHP league. It's also using this library as one option. Since everybody in the world is already using PHP 7.1, that's my first decision on the major release, the next major release. So if you open the file, you will see that everything is strictly typed, because I'm quite strict with types and decisions and everything. But in order to start using my library, the next version, you have to either choose a symmetric or asymmetric algorithm. And you do that by creating a configuration object, which is basically a small dependency injection container. And you start that saying, okay, I'm going to use HMAC 256. I'm going to pass it there as a first argument. So that's my signer. And the second is my signing key. If I want to use an asymmetric algorithm, I can do the same, but using an asymmetric algorithm. And you should say, okay, this is my private key, my signing key, and this is my public key, the verification key. So to create very, very, very simple token, you can just do this. You create the configuration object, and you get the token builder, and you say, okay, I want to configure the builder with this claim, and please provide me a token using this signer and the signing key. there you go. You have a token object that you can use. It's important to say that this object will be immutable, so you cannot change it, because a token, it's something that you cannot modify after you, like if you have a string, it will be only valid if you don't modify. So that's one of my design decisions here. But if you want to use the register claims here, you can say, okay, I want to use to create a token with that private claim, but that token will be identified by this ID, which in this case is completely random, and it's issued by me and permitted for these two clients. And that's the nice thing about the time claims. You can say that, okay, it's issued at now, can only be used after now plus 5 minutes, and will expire at now plus 1 hour. So you can, since I'm using, in this example, an asymmetric algorithm, this is the generated token. And that's what I said, okay, you have to know what you're doing and how many data you're using. Otherwise, you'll have such a big token that it's not really suited for you, basically. And the JSON that it generates is basically this. You can see that the list of claims there, the timing claims, they're not necessarily an integer. It can be an integer or an integer with some floating points. This is basically Unix timestamp plus microseconds. So you can have a lot of control and power to manage dates there. How can we parse token using that version of the library? You can just have the string and send it to the parser. The parser will just return a token if the token is it's parsable, right? There's no secret here. But one thing that many people forget about is validation. This is one of the most important part of using JSON Web Tokens. You have to validate things properly in order to rely on the information that is in the token. Otherwise, you might compromise security, especially when we're talking about authentication. So this new release also creates this validator that allows you to pass any constraint, which means you can create your own constraints and say, okay, I want to ensure that this token is whitelisted or is not blacklisted, or you created a random private claim and you want to validate that to make sure the claim is there, or if the token has the correct subject, I don't know, any kind of validation you want to do. And we provide two different ways to validate a token. The assert that will throw you an exception with a list of failed constraints. So you will know what you need to do in order to fix that token. And the other option is the validate, that essentially returns true or false. In terms of performance, I recommend you to use validate, because if the first claim, the constraint that fails, we will already return false. But and the assert will go through all the constraints and validate them all in order to create a list of things that you want to know and present there. So that whole story about how I managed to simplify my API. Well, I removed all the cron tasks. I don't have anything removing tokens from the database. Actually, I don't have any token in my database anymore. And that's pretty nice because the API is now faster. I don't have to do any kind of I/O check to say, OK, is this valid? Or is this user correct? I can just process things and create the response I need to create. It's important to say that some people use the authentication token also as authorization to add authorization information. You can't do that, but if the permission changes, it means that people will have to create new tokens. So you have to think about that. And that's my final message. It's all up to you. So depending on the use case you have to decide what claims you want to create, what library I want to use, how I want to validate something, what algorithm should I use here. And that's all, like a downside of the specification, because it's not foolproof, let's say that. The specification says that you can optionally use non-signed tokens, so a token without any signature. And as we said before, this is quite unsafe. You cannot rely on the information that is there. So developers have the responsibility to know how to do things and ask if they don't know. Essentially, that's the idea of the specification. And I'm really glad that I could create the library and help people to manage JSON Web Tokens. And now we have some time for questions. So do we have questions? Cool.
So you talked a lot about the server side of the fingerprint tokens. How about the client side? How would you store? Where would you store the token on the client side?
So are you speaking about the authentication use case or what?
Yeah, something just like where would you store the token?
Okay, so on the client side, you have essentially two options to use to access the token. The first one is when the server is using cookies, so you don't need to store and you don't need to send anything. The browser will handle everything for you. The advantage here is that you can define the token to the cookie to be HTTP only, and especially to use only SSL. So that means you have a value that nobody can read from JavaScript, right? Which is something that doesn't happen if you use local storage. That's the other option, right?
Yeah.
The advantage of using local storage is that the JavaScript client can just read information from the token and present, I don't know, if you want to add user data there, saying this is the username or the user ID, I don't know, anything you might want to add there, you can read that from the JavaScript side, which is kind of cool. If you're doing that, in order to solve the security issue, you should reduce the expiration time of the token, or even create a one-use, like one-time token. So every time you create it, the client sends a new request, the server responds with a new token.
Okay.
That ensures that nobody will be able to use a token twice.
Thank you.
You're welcome.
Really?
Up there. Ooh.
Sorry.
How expensive is it for the server to read the token or the data that's in the token?
It's actually not that expensive. I have some benchmarks on that library if you want to check, but it's like minimum. I don't have any. So the API that I was talking about, I was using the password API from PHP to manage passwords, basically. And it takes more time to verify the password hash than it uses to actually validate the token or create a token. So it's not expensive at all. Less than 20 milliseconds, way less.
Could you explain a bit more, because you mentioned like for the whitelisting and the blacklisting that, oh yeah, you can store list, but isn't that similar to like if you just connect to the database, and what's the experience of how you offset?
Yeah, it's indeed because you're adding the storage layer, right? The nice thing about like blacklisting, if you're using Redis, for example, you can set the TTL of the entry, and so time to leave. That means that if you're blacklisting something, the token identifier, you can Redis will automatically kill that if you set the expiration of the time to leave of the entry the same date as the difference from now till the token expires. So that provides you the blacklisting thing. This is like not exactly the same as using a database, because you're not necessarily storing all the information of the token. You're just saying, okay, this is the identifier, and maybe if you're whitelisting, this is the user that is using that specific token. But those are just examples that you can do to mitigate the problem that you have because when you create a token and you send to someone, it's there. You cannot roll back that. You don't have control over the generated token until it expires. Then it's fine. So if you don't want to use that because you're adding extra storage systems, you could rely on one-time tokens or tokens that have a short period of life.
Does your library avoid to use no algorithm or weak crypto algorithms?
Yes. So if you go to the configuration object here, yeah. That's one thing that I don't show. I don't have a slide for this because it's not safe for production, but it's quite handy if you're creating like for development purposes. So you can say that instead of for asymmetric signer or for symmetric signer, you can say for unsecured tokens or unsecured signer. I don't remember quite well what's the method, but that will basically create a signer that doesn't generate any signature. It will have an empty string as signature. The idea there is basically to let the users have the power to choose what they want to do. Like I cannot rule the world and say, okay, you must use my library in this way. You're free to do. If you want to get a shotgun and point towards your foot, you can do it.
No, I mean, but for validation, it's required to have signed by default, or do you have to specify this?
So if you're saying, let me show you here again. Here, there's the last constraint is signed with. The idea, and that's why I created this configuration object, so that you can put all the configuration in there and just use the same thing. Every time you're validating the signature, you must specify a signer. If you don't, you cannot use the constraint, basically.
Okay, so if you don't, you're doomed then.
Sorry?
If you don't, then you're doomed then.
Yeah, okay. If you don't want to validate the signature, you just remove that, and it's up to you.
Okay.
Cool. Thank you very much, people. And please, if you want to, if you want to share some thoughts and have some discussion, on my Twitter handle is that, GitHub as well. And I'll be here for the rest of the conference. Thank you.